Welcome to our fourth lesson. In this lesson, we are going to talk about identifying functions and using function notation. You'll notice that in your note packet, you may have a warm-up, lesson 4 warm-up. Go ahead and work on those problems and we'll cover those in class. For the video, we're going to go ahead and start out with our vocabulary terms. And the first term we're going to talk about is a relation. Now, a relation, mathematically speaking, is just a pairing of numbers. So any two numbers that are paired together is called a relation. The domain of a relation is a set of numbers that contains the first number in the pairing. The domain is an independent variable, it's the x-coordinate, and it's also an input variable. All of those three terms in blue describe the domain. The range then is a set of numbers that contains the second number in the pairing. These are the outputs. It is the dependent variable, and it's the y-coordinate. So our last term is a function, and a function is a type of relation where each element in the domain goes to a unique element in the range. Let's take a look at some examples to clarify what these words mean. So here we have a couple of examples. I know in your practice sheet, in your note sheet, you may only have A and B for examples. I went ahead and added an example in the video here for clarification purposes. So let's go ahead and start out with letter A. It says, which of the following are functions identify the domain and the range? So in letter A, we have 2 goes to 4, but -5 is going to 2 places. So this is not a function, okay? Because this 5 is going to 2 places, it's not going to a unique place. That means it is not a function, okay? We have to have every element in the domain goes to a unique place in the range. So letter B says 4 goes to 5, and then we have 4 going to 7. So that's a similar situation to what we have in A. So this is also not a function, okay? We have an element in the domain going to 2 places in the range, so that cannot be a function. What about letter C? Each element of the domain goes somewhere in the range, and it's a unique place, right? They can go to the same place in the range. You just can't have something in the domain going to more than one place. So this is a function. So I'll go ahead and write that in here. This is a function. And then we are supposed to also identify the domain. So the domain is the set that consists of the elements 3 and 4. And we want to use set notation, the goofy brackets, okay? So that's the domain. Then the range, usually we depict that by a capital R. Again, with our set notation, the range includes the element 7. The vertical line test is a test that we can use on graphs to help us determine whether something is a function. So it says this is used to determine if the graph of a relation is a function. So there you have it in words, and the graph is a function. When we use this test, it is a function if the vertical line intersects the graph no more than once. So as long as it only crosses a vertical line one time, then it is a function. Here's some practice using the vertical line test. It says determine if it represents a function. Well, in letter A, you can see in letter A, if we do the vertical line test, let me find a nice color for us here that'll work. And there we go, that should work. So if we do a vertical line test here, we can see that it crosses at more than one point. So this is not a function. Letter B, no matter where we put our vertical line test on letter B, okay, we can run a vertical line several times. It's only going to cross one time. So this one is a function. Letter C, if we do our vertical line test for letter C, okay, we can get it to cross once there. It looks like each point here, no matter where we draw our vertical lines, we can only get it to cross one point at a time. So letter C is also a function. Function notation. I like this. I think you'll find this to be a helpful screen for you. Has some good information here. So the previous notation and in function notation. So you're used to seeing things like y equals x plus 2. Well, in function notation, we would write that instead of y, we just replace it with a function f in terms of x. That says f of x equals x plus 2. F of x means the same thing as y. It's just different notation. So if we want to evaluate that function, we would say evaluate if x equals 2, and you know that you would plug in 2 for x. The way we would write that in function notation is this: we would say find f of 2. That just means instead of the letter x, we're going to plug in the number 2 in the function over here on the right. Here's another example for you. Y equals 3x minus 5. This one we might define as function g of x equals 3x minus 5. So the function letter is g. And again, if we wanted to evaluate that function at x equals 3, we would say find g of 3. So that's the notation and how that's different from what you are used to. So here's a problem, and it says if h of x is equal to 5x squared plus 2 and p of x is equal to x over 2 minus 3x, find h of negative 2. Well, in this example, we're looking at function h, so we're not even going to look at function p. It has nothing to do with the problem. We're going to look at the function h. And instead of x right here, it says find h of negative 2. So everywhere that we find the letter x, we're going to plug in the value negative 2. So here we go. We're going to say h of negative 2 is equal to negative 5 times, we're going to have whatever x's value is squared, and then we're going to add 2 to that. Well, what value are we going to plug in? We want negative 2 instead of x. So when we go ahead and calculate that, we're going to get negative 5 times negative 2 squared is 4, and then we will add 2, and our order of operations says we do multiplication first. This is negative 20 plus 2, which is equal to negative 18. So therefore, we have h of negative 2 being equivalent to negative 18. All right, in this slide it says, for each situation below, find the cost of a 2, 3, and 4-minute call and express the answers as ordered pairs in set notation. Identify the domain and the range, determine if the set of ordered pairs represents a function. So let's take a look at this. The company charges 25 cents per minute for up to 3 minutes and then 10 cents for every minute thereafter. So a 2-minute call, a 3-minute call, a 4-minute call. Okay? So what would this look like if we were to represent this as ordered pairs? So we would have the ordered pair 2, comma, 0.25. If I can draw straight here, it would be really nice. 3, comma, 0.25 would be an ordered pair. And then 4, comma, 0.35. Okay, so there is our ordered pairs. So it says express the answers in set notation, identify the domain and the range. So our domain would be the set of numbers 2, 3, and 4. And our range would be the set of numbers. We only have 2 in this one, 0.25 and 0.35. Okay? Determine if the set of ordered pairs represents a function. Well, it does. Each thing in the domain goes to a unique thing in the range, so this is a function. Okay, so yes, it's a function. How about for part B? Let's take a look at part B and see what we can figure out in part B. The company charges 25 cents a minute for plan A, 50 cents a minute for plan B. I went ahead and wrote a table for 2, 3, and 4 minutes. Hopefully I did my math correctly. And then let's go ahead and write in set notation what our domain and what our range would be and whether or not it's a function. Well, our domain is going to be the same set. We're going to get 2, 3, and 4 minutes. It's a number of minutes. Those are our inputs. Our range ends up being, I have a whole bunch of stuff on this one, 50 cents, 75 cents, $1, $1.50, and $2. Okay, so there's our domain and our range. Now, one of the problems we have here is we're taking, for plan A, we map 2 to 50 cents, and then we also map it to $1. So in this situation, okay, it's not a function if we're including both plans in the domain and the range, okay, because 2 gets mapped to 2 places, 3 gets mapped to 2 places, and 4 gets mapped to 2 places. Now, if we just say, is it a function just for plan A? Yeah, that would be a function, and plan B would be a function, but if it's all together, then it's not a function. That's it for this video. We'll see you in class.